Thank you. So basically, the C processor sucks, but it's also awesome. And, well, we'll get to it, I guess. All right. If you remember just one thing from this talk is that programming is about people. I know that we want it to be about the tech, but it's not. Trust me, I want it to be about the tech too, but it isn't. It's always about the meat bags. If you're not thinking about the meat bags, you're going to fail. So if you take one thing from this talk, that would be it. I'm done. No? Okay. Story time. So John Montague was the 4th Earl of Sandwich, and apparently, according to legend, he liked to play cards. He also enjoyed having a little snack while he was playing those cards, and he wanted to keep one hand free for the cards, one hand for the snacks. So he asked his valet to bring him some meat in between 2 pieces of bread, and voila, sandwich. The other guys that were there said, I want what sandwich had. The name caught on, and this is why there's a picture of delicious BLT up there. Why did I talk about that? Because it's a story, okay? So humans, for reasons, respond really well to stories. And people sensitive to storytelling. Research has shown that if you use a story to relay facts, people learn a lot faster, and their retention of the facts is a lot higher. In fact, if you put electrodes in somebody's brain, that's an actual picture, the brain fires up. It's not just one region of the brain that fires up. If you show them bullet points, you get one region of the brain firing up. If you tell them a story, the whole brain lights up, and things are better that way. So you're now unlikely to forget the story about how the sandwich was named, whether or not that story is even true, because there's no way to know. But you're not going to forget it. On the other hand, nobody's going to be talking about the slide at all, because it's boring. Boo. So that's why I told you a story, because stories are important because they're important to people. And like I said, programming is about people, so if we don't account for the people we're working with, we're not going to be successful. So the whole point here, I think, is that I think everybody in this room wants the adoption to grow, and if we keep forgetting this fundamental fact, we're not going to succeed in achieving that goal. So, again, programming is all about the meat bags. Drats. Right, so to contextualize the story, this is your basically who I am slide. If you don't get why it says why instead of who and who that blue guy is, then you haven't watched Avengers Infinity War, and all I can say is I feel for you. It's amazing, go watch it. So I've been a D user since 2013. Actually, this conference was a big part of that. I was watching the videos online, thought it was really interesting, downloaded the compiler, started trying the language myself, and very quickly also read the T programming language in one sunny afternoon from cover to cover. And very quickly it displayed C++ as my language of choice, my favorite language. So I started getting really into the D community and ecosystem and all that. The next year I ended up at DConf 2014 at the Facebook headquarters as a speaker, started meeting members of the community, really started getting into the swing of things. So I wanted to use D round about that time. Unfortunately for me, that was also the year in which my previous project at work had ended because we had achieved everything we set out to do. And so they had to move people to a new project, so they put me with a bunch of programmers I'd never worked with before. They were all C programmers, and we were about to take ownership of a code base that was written by a completely different team in a different continent. And they just handed it over to us, and now it was ours, which is every programmer's dream, right? Living the dream, taking ownership for somebody else's crappy code in C. So that was great. And the thing is, there were no tests, right? I mean, the previous team didn't write any. Well, they wrote a few, but there were hardly any. They didn't even compile anymore because they hadn't been running so long. And I told the team at the time, remember, they didn't really know me. We can't change the code until we cover it with tests, because or else we'll break it. I mean, who knows what we're doing there. I really recommend this book, which is instrumental in some of the techniques I ended up using to test the code we had, because it wasn't made for testing. They didn't have the tests in. The culture at the time when I was working at Cisco was really to do end-to-end tests on actual hardware. And the hardware obviously isn't a PC, so that makes things more complicated. They usually actually serial lines to talk to the boxes and type commands in, that kind of thing. That was the environment I was in. So reading this book's really good. I recommend it if you have to work with legacy code. It's mostly focused on OOP techniques, but it does, so Java, C++. But it does mention some C code techniques you can use as well. I didn't manage to get anybody else in the team to read this, but what are you going to do? The code base is in C. That doesn't mean I have to write tests in C. In fact, I don't think that's ever a good idea. I mean, there are reasons to pick C, although not that many, I would say. Basically, if you have a compiler for anything else, use that instead. However, you don't need to write tests in C. I mean, you're just making life hard for yourself for no reason at all. And so I had to decide what language to use. Now, I wanted to use D, but I ended up using C++ because it was easier. Did I like that choice? I did not, but I had to make it anyway. Now, why? Well, first of all, again, new team, and they didn't even do tests. This is a culture where they did manual tests and thought that was a good thing. When we talked to them about automation, they thought that was a bad thing. I don't know why, to this day. But it was. So there's a culture problem already. So I'm already fighting to even get the tests in to begin with. I counted the number of meetings we had to discuss unit tests. It was 8. I counted them because it was so frustrating having the same conversation over and over again and tried to convince people that unit testing was a good idea. At one point, somebody said, but you want us to do more work? And I went, no, I want to do less work. I'm a programmer, I'm lazy. That's definitely not what I want. I want to not break the code and not be debugging for days in a row. So if you're arguing, you're losing when it comes to persuasion, so don't argue. And basically, I was already arguing about tests. So this is already a situation that's hard enough to begin with, okay? I'm already trying to convince them. They don't know me. They've never worked with me. They don't trust my judgment or anything like that. Or I'm having to prove myself. So in a way, my career is on the line. So I have to try to make choices for this team that would make sense. And again, if you're arguing, you're losing. So also change, right? People hate change, it turns out. They really, really do not enjoy it. Well, most people. There are weirdos. But for most people, change isn't good. And if you're wondering if the slide title is supposed to be sung to song, it is. Most people have this naive model of change, which these diagrams are from Peopleware, by the way, which is also a great book that I recommend. In fact, anybody managing a software team should have to read this book before going forward. It's basically where I learned that it's all about the people. In any case, most people think you have an old status quo, and then a better idea comes along, and everybody is enlightened immediately and goes, hello, new status quo. Nope, that's not what happens at all. What happens is usually there's a foreign element, in this case, me, in that team, introducing an idea, then chaos, and then there's a bit of time so that they can get used to that, and then they practice, and then they get better at it, and then the new status quos happen. If you want to know more about it, like I said, just consult the book. And the change doesn't really happen until people feel safe. If they don't feel safe, they go straight back from chaos back to the old status quo. So you need to take this into account as well as the evangelists out there. Maybe the best way isn't to jump straight in. Maybe something like Better C is a way to get them in the language. It has to be piecemeal. It has to be easy. They have to feel comfortable. If they don't, it's not going to work. People don't like change, and I was introducing change as it was. There's also this phenomenon known from psychology called loss aversion. For probably evolutionary reasons, people prefer. Well, we're really averse to losing anything, and apparently some research shows and indicates that loss is about twice as powerful as gain. So it only evens out to people when it's about twice as much. So loss bad, gain good. Some of the psychology experiments, basically, if you give somebody money and then take it away, they feel that much more strongly than missing out on getting the money to begin with. So we don't want to trigger that aversion. We don't want them to feel like they're losing something by going down your path of change, whatever it may be. In my case, again, trying to cover this code base with tests. And automated testing was chaotic enough for them. Getting them to adopt D, that's a lot harder. So, I had to be able to sell that. But you can tell me, you can write the test in D, right? What's the problem? It's called the C code, no big deal. Sure, okay. So if you go to dlang.org right now, and I can't remember exactly what it's called, but C interrupt, whatever it is, that's the example they have. String compare. First of all, nobody's going to do this because it's already done for you in standard library. The declaration is already there. Secondly, if those are your problems, good for you. But normally, you're not trying to call a function that takes 2 const chars and returns an int. It's usually much, much more involved than that. In reality, it probably looks like this function I called weird API here, in which you have pointers to structs instead, and then some integer, and I called it weird API because naming is hard. Now, the thing about this is that foo will be in foo.h, bar will be in bar.h. And then if you go look at those structs, they have substructs within them that are in different headers, which if you go look into those, other structs, other headers, and this goes on and on and on. And the code base I was trying to cover with tests, that would recurse about 20 times. Completely different headers. So that's what the real code that people are trying to call looks like. It's a lot harder than that. And there's another problem as well, because you see int flags there. What'd you pass to it? 42, 33? Nope. You need the preprocessor, because that's how the API is designed to be used. Okay? So what you can do here, of course, is try to emulate the preprocessor using CTFE, for instance. That can work, but it's also manual. You need to figure out. And sometimes it won't quite work because the semantics is slightly different, maybe. Here be dragons. And also, so the way API is meant to be called is like this, with the preprocessor actually using the flags there, you're not assembling it manually. As you can see, weird API returns int, but in the call, nobody's checking for the error code because it's a C API, let's face it, every return value is an error code. And normal programmers don't usually check. And so what do we say to the god of error checking? Not today. Anyway, so that's what real APIs look like. And that's a problem. And then you get things like this. If you have nested structs, sometimes people write macros like this one to facilitate getting a member of a struct, because obviously writing code is more important than reading it, even though you do the latter a lot more. You can tell me, who would do such a thing? Psychopaths that write code that I didn't have to manage. That's who. But they do this. And it turns out that this shows up in the code all over the place. I kept trying to jump definition that function didn't exist because it was a macro. Can these things show up in APIs? They can. It's probably rare, but these are actual problems. And these are problems that I had in that code base. These aren't even theoretical problems. These are things that actually happened. So this complicates matters a lot. So what we can do, I could manually write all the declarations and recurse myself into headers and look at them and then do this and do that and look at if defs, because that's the thing. The struct declarations can use a preprocessor too. Which version do you use? How are you going to compile this? Are you going to do version blocks in D? Are you going to do static ifs? You can, but that is a lot of work. I reckon that it would be weeks and months of manual wrapping just before we managed to write the tests. Okay? I tried D-step. It didn't work. I don't remember what happened. I just remember it didn't work. And I at one point was trying warped, the preprocessor that Walter wrote, because I was trying to see if I could at least just run the preprocessor first and somehow get the declarations from out of that so I wouldn't have to recurse into the headers. Warp didn't work on it either. Sorry, Walter, no, I don't have a bug report because I can't remember what happened and I don't have access to the code anymore. And Calypso's a non-starter. I mean, yes, there's Calypso, but it's a fork of LDC that does this weird thing in which you can use C++ and D together. But, again, they don't even know D, okay? If I'm going to convince them to use a different language, and they go on the internet and look up how to use DMD, and I tell them, actually, no, it's this other thing. It's a fork of another compiler. That doesn't look good, okay? The loss of version thing will trigger immediately. They'll just go like, nope, don't want to. It's a non-starter. It's not a viable option. And so because of all that, I picked C++. Because, back. That is the elephant in the room, okay? And C++, this is all the work you need to do. The extern C might not even be needed if somebody wrote the header properly, but in this case they didn't, so it was. But that's all you need to do. There is no conversation happening anymore. You do this, it's done. All of the structs are now usable. All of the API and all of the preprocessor macros. And they work exactly the same way. There is no loss. It is as smooth as can be, okay? No argument here. So I did that. Also, I mean, these are C programmers. They didn't even know C++, okay? So that is also a bit convincing, but they could pretend to write C, sprinkle in some niceties maybe, like using std vector for the test, and really not have to be any the wiser. They can just write the code they already know, and it will work, and it will compile, and it will link, and it will do what they think. So this annoyed me, because I wanted to use D, but I couldn't, okay? For me, this was the advantage that C++ had. And I wanted this for D. I wanted it for somebody like me who wanted to use D to not have a reason not to. And that's the advantage C++ has. I think its rise to power, from a historic perspective, has everything to do with that. I don't think we'd be here right now if C++ hadn't done what it did, because Walter wouldn't have implemented the C++ compiler and wouldn't have invented D. And the only reason anybody's still talking about C++ is because it made the transition completely and utterly zero cost. Oh, you have a C code base? No problem. Just create a new file with the CPP extension. Everything will work. You can use your old APIs. Nothing changes. In practice, it's a superset of C. Yes, I know it's not, and I've run into edge cases where it's not. But in practice, it is. We can just pretend it is, and it's a first approximation. That's basically the case. Incremental adoption, no cost. There literally is no cost adoption. If there's no loss aversion. You can't be averse to something that doesn't even exist. You can't lose by arguing if you're not even arguing in the first place. If you're arguing you're losing, no argument. And I believe to this day that C++'s killer feature is hash include. It's one thing that differentiates it from anything else. It is the one thing that caused me to pick C++ for this project instead of D, because there is no work involved. So my conclusion, of course, is to shamelessly copy what C++ did. That's how it rose to world domination. That's how it conquered so many people and swallowed up whole projects. I mean, even GCC is in C++ these days. So let's do that. So what do we want it to look like? This. This is a hybrid Frankenstein monster of my creation. If you don't look carefully, it just looks like I wrote C code, but I didn't, right? Because you can see a scope exit there, and a const without an auto, so it's not even C++ either. So that's D code, except it's not, because there's hash includes, which isn't valid D. So I want this to happen. I want to be able to write this code, and I want it to compile, link, and run, and do what it's supposed to. Incidentally, those AF, SP, and NNPub values there are macros, because that's how you're supposed to use the API. It always happens in any non-trivial C API. You always need a preprocessor somehow. It might just be constants, but it might be something more involved. So this is what we want to do. I want to replicate the C++ experience of interfacing to C. I want it to be as painless as it is when you write C++ and are interfacing to C. I want everything to just work and not have to think about it. The other thing about this as well is that I don't want to see any D declarations from the headers either, because why would you? That's for the compiler to know. And if you want to know what the functions you're calling, go read the header. I mean, C code isn't that much different anyway, so just go to the origin of the code you're calling, go look at the declaration, and that's fine. So how do we make this work? Well, like dstep, DPP uses libclang. I call it DPP kind of for marketing reasons, I hope. I read it either as D preprocessor or D++, take a pick. So first we use libclang, which is a C API on top of the Clang front end. And that way we can call into Clang's parsing engine via D, so we're using the C API. Then we take the AC that we get from the headers and we translate those into D syntax. We do have to deal with some impedance mismatches here though, because for instance, C, you can have multiple declarations, you can have as many as you want, as long as there's only one definition. But not in D. So we need to fix that. But the thing is that when you're including a header, you don't get things in the nice order, as it were. So you need to go find out which one of those you want to actually use. For instance, for a struct, you can do struct foo, semicolon, several times, and then have a definition somewhere else. So we need to find that one. Now, libclang does have a concept of what's canonical. You would expect, naively, that they would pick the definition as the canonical one, but they don't. So I have to do some filtering basically after it's been parsed to actually get the information I need, because I can't repeat myself because the decompiler won't let me. There are other little issues as well. And then the idea is to take those headers, expand the translations in place, just as they are there. Basically what the preprocessor does in C and C++. And I originally did this per header file. That didn't work once I found a bug, because there's a big C project, I think it was Postgres even, in which you're required to include a certain header before you can include any of their other headers. So their headers aren't self-sufficient. If you don't put the declarations here, the other ones don't work. So I can't do that anymore. So what I do is I take all of the headers, all of the includes I see in a DPP file, copy them somewhere else in the file system, and then parse that alone by itself as C or C++. The translations are meant to be checked in, which means after you convert C code to D, I don't actually want to look at the file. To me, this is just part of the build system. Okay? You generate some D code as part of doing your job, but you don't actually look at it. That's not what you're working with. So they're not it's a different philosophy from DCEP in the sense that instead of translating and then importing that module, you don't. Right? You don't look at it. You just, again, replicating the experience. I want it to work just as easy as. And the other big difference, of course, is macros. What do we do with those? Now, by the time you've used libclang, it's a compiler, okay? The first step in compiling C or C++ is a preprocessor, but by the time you've parsed, the preprocessor is gone. It doesn't exist anymore. All of the macro declarations are gone. However, probably because somebody else is doing something similar to what I'm doing here, libclang is an option when you parse a source file that it remembers where the macros were, even though they're gone. So you can query it for the macros that were in those headers. And then what I do is redeclare those macros in place. So if I have defined foo something, I go find out where foo was, go open that file, read it from this position to that position, which is where the definition is, and paste it in line. Exact same definition. Because instead of fighting the preprocessor, I figured just use it. I could use warp to something like that, but instead just call the C preprocessor. So the idea is expand all the declarations in line, take all the macros and paste them in here, and then run the C preprocessor in the result. That means your code, the user code, the code that the user sees after the includes, can then use any macros that were defined in those headers. And then the C preprocessor takes over, expands those for you, and everything just works the same way it would have done otherwise. Is it hacky? Yes, but that's how we do it. If you can't beat them, join. And then, of course, at the end of this process, you have actual valid D code, right? Because this here isn't. This isn't valid D yet, but it becomes valid D after this process of expanding it in line. So what the compiler will see afterwards is those includes are gone, and then you have a bunch of definitions there. Yes, Walter.
So you're running the preprocessor also on the D code?
Yep.
But then you've got a, it expands to C code.
We'll get to that.
Okay.
So the good thing about this is, and then we call it decompiler the resulting code. The good thing about this is I'm wrapping the compiler, all right? It's a layer on top of it. It's not replacing the compiler. It's not a fork. Those things are scary. This is, chocolate bunnies and flowers, because there's nothing to be scared about. The compiler's just doing its thing. I'm just pre-processing beforehand. Again, I'm shamelessly copying for C++. The first implementation was it pre-processed what became C++ into C and then compiled that. Yeah, let's just do the same. So that's how it works. But yes, there's problems with that. I'm not entirely sure how to fix it either. So how do I call libclang from D? Fortunately for me, Jacob wrote DCEP and already had the bindings, so that there's libclang declarations in D syntax. Because obviously I have a chicken and egg problem here. I can't use this project to, translate. What I did do, though, is I added safe no GC pure no throw to every single one of those declarations. Now, is it safe? Probably. I trust those guys. Is it pure? Look, if a pure tree falls and D doesn't see it, it's pure. It's fine. It's obviously no throw because it's C API anyway. And I also added into all of the parameters. The reason I did all of this is because I hate writing code that's not safe, that's not pure, and that doesn't use const. Okay, that deeply disturbs me. So I did this. I basically trust the libclang implementation, and I do make one exception for callbacks because the way they do it is basically they kind of implement the visitor pattern in the sense that you give them a function that they run on the ASC nodes. And I can't guarantee that that function is going to be safe or pure or whatever. And also I can't limit what users can do calling libclang, so I don't do it there, which is the only place I can't. But the good thing is I can write safe code, pure, and also use const values everywhere, and things work. I mean, I haven't corrupted memory yet that I know of, so it probably works. And then I wrote OOP-like wrapper for the C functions, right? Because they're annoying to use, so we just declare a struct, some member functions called the C API. There's a few other things I did as well. I put all the enums into their own namespace, so they're easier to use. Sometimes they don't look exactly the same as what's in the header, so I have to go back and forth, but I still think it's a lot nicer to use it that way. So that's how we call libclang first, and then we just tell it to parse, because that's what it does. So in the implementation, what we do is, so libclang in its parlance, the AST is made of nodes. They're called cursors, and cursors can have types or not, depending on what kind of cursor. For instance, a namespace cursor doesn't have a type. That doesn't make any sense, but a function does, a struct does, etc. And so we go through, so at the head of the AST is a cursor that's of type translation unit, and then it has children, so also cursors, and then you loop through those. And each one in turn, you translate differently. So I had a big switch case in which you're just switching the cursor kind. They can't use the word type here because type obviously means something else in the language. So each cursor it can be a different kind, a struct declaration, a function declaration, etc. And so, I mean, this will look familiar to a lot of people because this is not, rocket science, so I'm not reinventing the wheel here. Funnily enough, I took this version from where I hard-coded the name of the struct. So this worked as long as your struct is called foo. It's like Henry Ford's car, right? You can have any color as long as it's black. Same here, except foo. And then, the struct declaration stuff, it makes sense. You take the struct, you declare the name after, of course, I fixed this. You loop over each field, which is the child cursors within it, and then translate that. And this is in a top-level translation function that just dispatches to whatever it needs to do. However, I hate this pattern. As you can imagine, this code could grow and get several pages long. Don't like that. So I actually think it's really good, and this is the reason why I'm showing it. I think every single time you see this pattern and you have more than just one line per case, I think you should do this instead, right? What I did there is I have a bunch of translation functions, each for a different kind of cursor, and I put them in an associative array, and then you just dispatch based on that. The good thing about this is you never have to write default, and you never have to worry about either, because if it's not there, you get a range error. So I use this technique in any language you can do this easily, including Python, D, etc. Because again, you never have to deal with the default case. It's handled for you by the machinery of the associative array. And also, this is a lot nicer, smaller. The dispatch becomes this, and then you can go into each individual function to see what they do with the cursors that they're supposed to handle. And then the technique here is cursors have children, and then they can have children, and they can have children. So you keep recursing the AST until you translate everything. All right, I forgot. I think I forgot a slide here. Anyway, so what you do is you recurse on them, and the cool thing about this is that I wrote some code to translate arrays. Okay. Now the thing about static arrays is the order of the numbers in D and C are the other way around. And I wrote a function to translate 1D array sorts because that's easier. Then I wrote some tests for 2D and 3D arrays going, haha, I'll get you now. The test passed. What? Turns out by using recursion, I didn't have to care. It just fell out naturally. And that's the other good thing about TDD is I didn't have to write that code either, because if I approached it assuming that I needed to deal it separately, the code would still be there, handling it separately, and being complicated for no reason. Write the test, it passed. Wait, that's weird. Verified it actually, works as intended, and then I didn't have to. So that was cool. So you just keep recursing that. This top-level translation function keeps dispatching to itself at the end of the day. So you go into fields, and the field might be a struct, so it goes back over here, and then everything gets handled for you, and there's no special machinery to really have to deal with that. I also want to say something about testing, because I think it's really important to basically write your own test framework for each project you work on. The test should be easy to write and to read, and you shouldn't get lost in the machinery of verifying things, okay? So this is actual test code from the project. I don't think I need to explain what it does, right? It's more or less obvious that I'm taking C code, right, some D code, and that stuff should compile. Now, the other thing I think is important about this test is there's I think a mistake a lot of people do when they're writing things that translate code into other kinds of code, which is to write tests that assert that the output looks a certain way, right? So if I have the C code, this D code must look like this. I think that's a mistake because the compiler doesn't care how you format your code. And that's a brittle test. You change anything about the test or the implementation, and suddenly you have 50 tests breaking, and for no reason. This is the worst kind of test possible, a test that cries wolf. It's broken, but the code hasn't actually broken anything. So I think it's important to show that I believe this is a much better kind of testing. What I'm doing here is instead of asserting that the output looks a certain way, I'm actually trying to compile D code that has included that header, and then doing static asserts on properties that should be true regardless of how the formatting happened. And therefore, this can never break, right? It can't. So yeah, I think this is really cool that, obviously I had to write the function should compile first, but then when you do, you keep using this over and over again, and now your tests are more compact. It's readable, you don't really have to explain to people. I'm also using these quoted strings here for code. I mean, they're only meant for decode, and I'm also using it for C and C++, but the syntax is close enough that Emacs doesn't care, and it looks pretty. I mean, just try it. It's a common refrain with me. Just hack around, does it work? Yay. Don't think about it anymore. The other thing that's good about this is also you do need to be able to debug when a test fails. Because if this fails, all you're going to get is saying, yeah, I couldn't compile it. So I made an effort to, this is what happens if you change this 16 size of here to 15. So you get this instead. It said you can't execute DMD in this code. The error was that static assert wrong size of foo, and then it prints out the D code that I actually translated with line numbers so you can actually look. And you can see that the line numbers start at 53 because there's a preamble. I don't want to look at that. I mean, that's always the same stuff, and it's just going to take up space on my screen. So I think this is important as well to show how my approach, at least, to testing and you know, trying to make things easier for myself. I hope it catches on. Yeah, right, so that was what I was talking about for recursion. I did have that slide, it just was in the wrong place. So you recurse and keep dispatching test-driven development for the win. There's another time, actually, which TDD saved me. I didn't have to write the code. I learned that you can return void, you can do return function call, and that function call returns void. I didn't know that until I wrote a test assuming that that would fail, and the test passed. I went, oh. I don't have to do anything after all. Again, if I hadn't done that, I would have a static if there somewhere, and for no reason. It's a lot simpler. So, things that I learned about C even after 25 years of writing C. Once you start looking at real projects that people actually wrote code in, seriously. So apparently this is valid C code, okay? You can have a function pointer called y, and also a struct y, even in the same struct declaration. This is fine. Now, of course, in C, what happens is you have to say struct y unless you have a type def. And then you say to me, what about C++? Well, it turns out C++ doesn't need to use struct whatever, but you can. So if you include this header in C++, you can disambiguate which one you mean by one saying struct and the other not. So I had to deal with this by renaming things. But I didn't know I had to deal with this until bug report, GitHub. Also, I learned that macros can have the same name as a function. And the particular case I was looking at is because so they could inline it. I guess before compilers did it, I don't know how old this code was, but the definition of the function just had the macro inside curly braces. Basically returned this, right? So that can happen. Now, the way C does with it, because think about it, if the macro is the same name as the function, wouldn't the function get replaced in the header? Not if you put parentheses around it, it doesn't. That prevents macro expansion. Who knew? But people write real code like this. I mean, if you actually try to use real libraries in the wild, this happens, so you have to deal with it. And you can't do the same thing in D, right? That declaration in D isn't valid. DMD will not accept that whatsoever. So I can't put parentheses around things. I have to rename them again. The good thing is that pragma mangle is a thing, so if I rename any functions, I can just tell the compiler how to mangle it, and it'll link fine. So that's fun. Macros as well, super fun. So it turns out there's some flies in the ointment when you try to use macros as they are, because as Walter pointed out, they're C code, they're not D code. And in fact, they're not code at all, they're text. So if you have, for instance, pointers, right? We don't have arrow syntax in D, but that's easy to fix. You just, any mention of an arrow anywhere, replace it with a dot, you're done. Size of x is now x dot size of. Again, you replace it. However, what if it's not exactly size of x? What if there's a space? What if it's in the middle of something? I had to use regular expressions. I'm not proud of it, but what are you going to do? Then I found out there's a lot of C-casting macros, like void star. Somebody actually defined their own null. Again, possibly before standardization, who knows? But they were casting 0 to void star in such a manner, so I had to deal with that too. So, okay, how do we do this? You look at the macros, you look to see if there's anything in parentheses that looks like a type. Void, void star, int, that kind of thing. What happens? Lathe files another bug because he finds something like oops4. A user-defined type in the cast. Okay, so now I have to remember all the types I've looked at before and see if any of them show up in parentheses somewhere. Okay, what about if it's a macro parameter? I don't even know if I handled that one. So this is hard, and these macros happen in the wild, and the goal is to be able to use them. I'm not entirely sure how to solve this problem because, like I said, I had an idea to take whatever the text of the macro is and then write that to a file and put libclang on it and parse it. The problem is it doesn't have to be valid code. Some of the macros are only valid code in context, okay? So you have this one here with the struct initialization. That's not always valid code. It depends on how you use it. In this case, to initialize a struct with another macro inside of it. But I can't just look at patterns like this. At least I don't know how to write a program that looks at patterns like this and figures out what the macro is supposed to do. As a human, I can tell, especially because of the name. But I don't know how to write a computer program that can do that for me. For instance, the braces might be a function declaration. I've seen macros like that, just to write code for you. Which one should I do? I don't know. And also, if I have a macro with a bunch of parameters, what are those parameters? Are they numbers, strings, quoted strings? I don't know. As a human, I could probably guess and look at code examples, but the computer can't. Or, again, I don't know how to do that. So this is a hard problem, and I'm not entirely sure it's fixable. And basically, I've just learned to live with some of the macros not being usable. For the most part, it seems to work, so I'm not too worried about it, but it is an issue. So does it work? Question here.
So what about like doing the correction of those macros after the macro expansion, because then you know a little more about the context in which they appear?
That was actually John's idea. Basically, look, so we can cheat, right? If the macros are never used, it doesn't matter. And if they are used, you can see how the user used them and then do that. That is an idea I'm going to explore. I just haven't gotten around to it yet. So this code here, does it work? I copied this. This is one of the tests. This works today, right now. Okay? So you can use nano message and just include that header and call into it. What else works? As an example, as soon as I get back to the slide. Curl. So I look at libcurl. That was one of the first ones that I was proud to actually be able to use properly. And I wanted to make sure that I wasn't just, translating gibberish. So I went on the internet and I looked at a curl example in C. Copied the file wholesale, pasted it, and then did 3 changes. I put 2 strings on the string literals because they're not the same as in D, right? I changed fprintf to stderr, right, Ellen? And I put stdconf text in there somewhere. Those are the only 3 things I did to the C code. It runs exactly the same. Include python.h. That works. Macros and everything. Writing a replacement for PyD using this. And the good thing about this is it will just work. For instance, when Python went from 3.6 to 3.7, PyD started crashing. And the reason for that is they added a member to one of the structs in the header. And of course, you have to update the daemons bindings by hand. This would not happen here. It would just be part of the build system. Header change, go, boom. Oh, okay. I was wondering what you're doing there. So, it would catch this kind of errors, we had it crashing first, then I had to figure out why, then look, I had to actually look at the change logs for Python, basically, to see what happened and why it was crashing, which is not what you want to do. I managed to come to the C standard library by just including stdio and using printf, that worked. malloc as well, free. I didn't try anything after that, basically, because, it works, ship it. So, except for bugs, yeah, it works. I mean, right now, you can probably include whatever C library you want to call and use it in D. I mean, Robert mentioned that the other day. He just used DPP to translate the header files, and he was done. It took a little while, but it works. The interesting thing about this is, first of all, of course, this is, I think, monumental, the fact that you can just call it to C easily as this now. If I had this at the time, I might have tried to convince the team to write the test in D. And the other thing I realized the other day that I still need to write a blog post about is, if you combine this with auto-wrap, the easiest way for you to call C from Python is D. Translate the headers into D, reflect, generate, off to the races. Build system detail at that point. So I think this is huge. Yeah, this is actual code from that project I was mentioning. You just include Python. I thought it was really cool. I could determine if it was Python 2 or not by using D on a C struct. Does this type exist? Oh, Python 3 then. And then you can use this in static ifs and stuff like that, which is a lot nicer than any other way you could have thought of, right? And yeah, I didn't show the rest of the code, but there's macros in there as well. I basically demacrify things by, in this file, using either a template mixin or some kind of thing like that, and then expand the macro in there. So then you can mix in that template because it was supposed to be code generation. Some function-like macros, I basically turned them into a function by writing the function and then return expand macro. So I think it's pretty cool. And it will just work. And if you need to use different compiler flags, maybe you have if-defs in those headers. Maybe there are options to using Python that you want to reflect in the library. You can't do that with normal bindings unless somebody writes version statements and static if and keeps those in check. Here, it just works. Just pass -d whatever to DPP and it'll work. So the holy grail for me would be actually to, well, supplant C++, but being able to do that. Okay? Just include a header from the standard library and then use the C++ standard library. Or any other C++ library out there. It has to be this easy, because or else people aren't going to use it. Nobody's going to consider moving away from C++ unless it is this easy. So I think that this has to happen. And never mind the standard library. What about Qt? What about eigen? I have a friend of mine at CERN. He said, these sounds really interesting, but I need to call into eigen. I went, well, yeah, you're out of luck. There's no other way you can do it. Heavily templated library. No other language can do it either. So it has to be this easy, but I'm trying to get there. But it turns out, who knew, C++ is a teensy-weensy more complicated than C. Somebody should have told me that. Also, libclang is not everything it's cracked up to be, it turns out. For C, it's fine. It's got all the functionality there. But for C++, there are a lot of things that are missing because nobody's needed them except me, I guess. So their C++ API is obviously going to be able to do everything because it is a C++ compiler, but whether or not that's available in the C API is a different story altogether. So for instance, there's no way to query for context. It'll tell you it's a const value, but it won't tell you it's a constant expression at all. No way in the API. So what do? I cheat. I look at the tokens, and if const extra is in there, enum. What are you going to do? It's ugly, but it works. There's no way to get a struct's template parameter, so I'm bending over backwards right now to get things to work, especially with template specializations. It's an absolute nightmare. Then you have to have an algorithm to output either a destruct or a class because C++ doesn't have the distinction. So now you need to look at how this type is supposed to be used. I haven't done this yet, but I'm pretty sure that it's enough to use class if and only if the type has virtual functions. Because I can't see how it wouldn't be a class otherwise. There might be some weird hybrid types out there. Let's just pretend they don't exist. They probably don't. I think that'll work. But certain things can't be translated at all. For instance, its reference from the standard library, from type traits. I was trying to avoid type traits, but it turns out as soon as you include the C++ header, you're including type traits, whether you want to or not. And I can't write this in D because there is no such thing as a reference type. This is a template in C++ that's specialized for references. I can't write that. There are no reference types. And so if I can't write that, I immediately realize, hang on, this is probably going to be used in Sphinx somewhere. I can't write that either. I don't know how to fix this. I'm going to have to see. But however, I think there's a silver lining in the fact that D is the only language that has any hope of translating any of that. Because I looked on Google today, template specialization languages, and since it didn't show up on page 1 of Google, it doesn't exist, as we all know. The universe is contained in page 1 of Google. So there aren't any other languages that can do this. We can't even, think about it anywhere else. So D at least has a hope. How? I'm not sure. This is going to be interesting. I mean, as a human, I can look at enable if and figure out that this is a template constraint. Can I write a program to do that? I'm not sure. I can hack around the C++ standard library. So we're doing this at work right now because we have some code written in C++ we want to call from D. So we're just ignoring boost in the standard library altogether, saying ignore this namespace, ignore namespace stud, ignore namespace boost, just hand me everything else. So what we do is, in this case, there's a function that takes a reference to a const vector. We ignore it, there's vector nowhere, and then we declare vector ourselves like this. And then obviously the member function. And this works reasonably well. I'm speeding up now because I'm running out of time. Well, I'm nearly the end anyway. So, in conclusion, programming is about the beatbags, okay? The apes ruin everything, but we have to work with them. So if we don't take them into account, it's not going to work. If you're arguing, you're losing, so don't argue. Just make an easy transition for them, and it'll be much more likely to get adopted. I've tried to out C++ here. I'm trying to replicate what it did to succeed the way it did, and be partially successful. And go forth and include.
All right, guys, you know the drill. Raise your hands if you got a question. I think Stephen over there was first.
So I saw you had line numbers starting at 53. Have you considered putting #line into the
That was just for the test. That was just for testing purposes. So the test will take the C file, translate it, take that decode, write it into a file, and then run the compiler on it. So that's the result of translating. That's what those line numbers were.
So when you actually call DPP on a file, it gives you the original line numbers from the C files and the.
Oh, I see. Yeah, that's interesting.
All right.
Yeah.
Right. There's a very similar problem in like Python, for instance, where you have the exact same problem. You want to be able to talk to existing C++ libraries. You want to do Qt bindings. You want Qt bindings. You want to do what you said. I forgot the name of that mathematics library. Whatever bindings. Yeah, thanks. And exactly. And so there's a bunch of existing interface generators for API bindings like Swig or SIP on the Python side.
Swig is hell.
Yeah, I know, believe me. I've looked at that myself, but is there any hope to getting that sort of technology up to shape because potentially you could get other languages invested in the effort?
I don't know. I'm not entirely sure what the question is.
I mean, is there any hope for... Sorry, I mean, is there any hope for technology like Swig, or does D have to go it alone?
In my experience, no, because we used Swig at work to bind C to Python, and it was a complete nightmare. I mean, the manual work we had to do was off the charts. And again, if I'm a programmer, I'm lazy. I don't want to write anything. I want to tell the computer to do it and have it figure out.
Stefan?
Have you figured out, have you tried to patch libclang to export the functionality you need through the C interface?
I'm going to have to at some point. I'm just going to have to send pull requests their way because nobody else is going to do it.
Yeah, that's going to be fun.
Okay. I'll go over there first.
Translating a lot of C++ code, one problem I've really run into is a class that has virtual functions that is basically kept on the heap. And I don't have a good translation for this in D, and I wonder if you've run into this problem.
Class? Just use a D class.
No, I'm on the heap.
Yeah.
Okay. Sorry, I meant on the stack. I mixed it up.
I guess, well, but that would be in user code. That wouldn't be the interface, though, right? I mean, if somebody's using that type usually on the stack, you don't have to from D. And even if you do, you could use it in place.
It's fine until people start returning it. Like C++ doesn't really enforce memory protection or anything like that.
Yeah, that's a problem. Especially because right now, I mean, even in the latest compiler, you can declare a copy constructor, but the bindings don't quite work yet. So returning and passing by value doesn't work right now.
You can have a class stuck on the stack if you just use the scope storage class.
Yeah, and then in place it, sure.
It seems to me like if you're looking at, sorry, let me restart. How do you handle inlining? Specifically, how do you handle functions that are declared inline and contain the body inside the header? Like, is there any hope to do this without doing the entire C++ compiler?
Well, I'm crazy, so I've punted on that, but basically my plan was to translate the body. Because I'm nuts. I don't see any other way. What I've been doing so far is forcing the instantiation, the same with templates, basically. So I have a C++ file or C file. I force instantiation there and then link. So that's the workaround I'm using right now, but the plan would be to translate. Because that is a cost, right? That's not exactly the same.
All right. Anyone else? No, looks like we're finished with questions time. Then thank you, Átila, for your talk.